In this lecture, I am going to show you how we can split our class information across multiple files. So far, what we have been doing is really cramping everything in the main function. We had our constant declaration, we had our cylinder class definition, and we had our main function to use these things all cramped into the main CPP file. Now we're going to see how we can do things better. The first thing we can do is move our constant in another file. Because if you think about it, users of your class in the main function don't care about this constant pi. Because it really is an implementation detail that should live somewhere else or even inside the cylinder class. But we're going to put this in a separate file because that's going to give us room to put other constants if we need to do that. So if we split things up like this, when we want to use the pi variable, we will need to include the constants file because that's going to give us access to it, but we don't have to maintain it in the main function. So this is a little better. But another thing we can do is move the cylinder in another separate file and do something like this. So now you see that our cylinder declaration and definition has moved in a file called cylinder.h, and we have our constant pi living in another file called constants.h. And if we want to use our cylinder class like we have been using it all along, we will need to include the header that brings it in. And this is how we're going to do it. And we will be able to use it in the main function if we set things up like this. But we can go even further. We can split our class declaration and definition in two separate files. What we're going to have in the header is going to be really a preview of the class, and in the CPP file, which is going to be called cylinder.cpp, we're going to have the implementation details of our class. And again, this is going to make things a little easier to manage because it's really not good to have everything cramped into your main CPP file. It should really have high-level details about how your application works, and all the low-level details should be split into different files. This is good design. Now that you have an idea about this, let's head over to Visual Studio Code and show you how you can do this. Okay, here we are in our working folder. The current project is class across multiple files. We're going to grab our template files and put them in place. And we're going to open this in Visual Studio Code so that we can really play with this. This is going to open our folder. We can open the main CPP file. We are going to clean it up a little bit, and we are going to grab our class definition and put that on top here. So this is our cylinder class. We have the constructors, we have the functions, the volume function here, and we have our setters and getters inside. Down we have our member variables, which happen to be private to this class here. Now, what we want to do is to organize our code better. And the first thing we need to do is to move this constant from the main file here because it's really not that useful at this point here. Users of your classes won't really care about what pi is because it is an implementation detail to the cylinder class because we are using that to compute our volume. So this constant really has no business being in the main file. We're going to move this in a separate file. We're going to set up a new file. We're going to come to the left here. Click on the plus icon here that says new file. We're going to say constants, and we're going to call this constants.h because it's going to be a header file. And we can just come from the main CPP file. We're going to copy this. We're going to cut this actually, and we're going to put this in our separate file, which is constants.h. After we do this, we're going to come in our main CPP file, and we're going to include that header file. So let's do that. We're going to include constants.h. And the moment we do that, you're going to see now Visual Studio Code knows where this constant is, but we don't have to deal with it directly here. Another benefit of doing things like this is that we can go in this header file and declare thousands of other constants, and we can have access to them in the main function by just using this single line that includes our file here. So this is good design. If we build our application, you're going to see that it is going to work. Let's try and set up a cylinder object. We're going to say cylinder1, and we're going to put 10 and 10 in as our parameters, and we're going to print the volume of this little guy. So this is easy to do now. we're going to say volume, and we're going to print that out, cylinder 1, and we're going to call the volume method, and this is going to print our thing. And again, I am going to be using the terms, functions, and methods interchangeably in this course, and what I mean in the context of a class, that's going to be the member functions of a class. So don't be confused by this right here. If we build and run this application, it should be working right because we have everything we need for it to work. Let's see if the build was good. The build was good. We can bring up a terminal and actually run this. Let's clear and run Rooster. This is going to print our volume. So the code is working right. The second thing we want to do is to move this class altogether in another file because we don't really want to see it here. In the main function, what we really want is to use stuff and we don't care about how those things are set up. In the same logic we used when we used std_string. We didn't really care about how std_string is put together. All we really wanted was to include the class that brings it in and use it in our code. We're going to be setting up the same behavior for our cylinder class here, and it is going to be living in its own separate file. So let's set up another header file. We're going to call this cylinder.h, and we're going to grab our class definition altogether. So we're going to go from the bottom here and select everything that includes our class. We're going to cut this out. We're going to go in our cylinder header, and we're going to paste this in there. And we're going to come back to our main file and include our cylinder class. So let's do that. We're going to include, and we're going to say cylinder.h, and this is going to make things work. Remember, the preprocessor is going to put these things in. The preprocessor is basically going to go in constants. It's going to take whatever is inside, and then it's going to paste that here. And it's going to take everything inside our cylinder class and it's going to paste that here. So it's basically going to be like we are declaring these things in the main function, but our code is going to be better organized. Now, if we try to build this program, it is going to build exactly like it did because we have all the information for it to build. Let's build. Build is finished successfully, so the build is good. And we can run this program and it's going to do what it was doing all along. We can clear and run Rooster. Don't worry about Visual Studio Code here. I don't know what the problem is with it. It's just having a problem with the pi constant here because it's not included in here. So what we can do is say include and include our constants header. And if we do this, the problem here is going to go away. But we're going to have a problem if we try to run this program now. Because try to think about it. In the main function, we are including the constants header. And in the header of cylinder, we are also including this little guy here. So if the processor comes, it's going to include this and it's going to have this little guy inside our main function. And the cylinder is also going to include this because it's including this header. So when the preprocessor is done, we're going to have our constant here declared twice. And if we try to build this program, you can expect bad things to happen because it's really not good to have the same thing defined more than once in your entire program. And let's try and build and show you this. Hopefully we're going to get a compiler error, and it's going to blow up in our face. It's going to say error redefinition of const double pi. So what is going on here? We are including this thing twice. Once here, and the second time it's coming in directly from the cylinder class because we are including that in this location here. And what the preprocessor is basically going to do, it's going to copy the entire file here and it's going to paste that in the place of cylinder.h here. And this constants header is basically going to be included twice. So it's going to be redefined here. That's the problem we have. One way we have to solve this in C++ is by using include guards. And the way we do that, we come in our constants header and we say pound if and def. This is a way to say if something is not defined yet, and let's say cylinder underscore h, and we're going to say define cylinder underscore h, and we're going to come down to the end and say and if. This is a way we have to tell the preprocessor to only do something or include the code we have within these things if the condition on top here is satisfied. So for example, the code inside here is going to be put in our C++ source file if the cylinder name here is not defined in the eyes of the preprocessor. So it's going to say if cylinder underscore H is not defined, I am going to define that and I am going to put this code here. But if it's already defined, it's going to skip all these things and it's not going to include this. Okay, so this is the logic here. And notice this is really not a cylinder file. So we're going to change this to constants underscore H. Let's say that. And let's do the same here. And this is going to do our thing. And we're going to go in our cylinder header and do the same thing and put in our include guard. It is basically a guard that is going to guard against something being included more than once. So let's do that in our cylinder header. So we're going to wrap this inside our include guards. We're going to say if ndef. You see Visual Studio Code is really helping out here, and we're going to put in the name we're going to use for this. This is a cylinder class, so I think it makes sense to call this cylinder underscore H, and we're going to do the same thing here. Define cylinder, and we're going to end f at the end of the file here. So we're going to say end f. And again, this is the syntax of the preprocessor. I don't want to get too much into this because we will learn about this later in the course, but we can now use this to guard against something being included more than once. And if we try to build the program now, hopefully it's going to build. Let's use GCC. And now you see that the build is good, even if we are including the constants header multiple times in the main file here. We can even go down and do that like 1,000 times. So let's do that. And you're going to see that if we try to compile, it is going to build fine because now we have a guard guarding against including this thing more than once. The preprocessor is basically going to come in here and say, if the constant's name is not defined, I'm going to define that name and I am going to put the code here in the source file that includes me. If it happens to be already defined, this condition here is going to fail. It's not going to do any more thing in this file. The preprocessor is basically going to give up on this file here. This is what I want you to know. So now we should be able to split our code into multiple files. And now that I think about it, we don't really need to include the constants header here because it's going to be brought in by the cylinder class, but it was a good opportunity to teach you about the include guards here. Now that you know this, we're going to remove this and we're going to build and show you that this is going to work anyway. So build is good. We can run our program, clear and run Rooster. This is going to work. The last thing I want to show you is that we can go even further and split our class into two separate files. Because people who come to the header file are usually interested in your class definition. They are really not interested in your implementation details. For example, they want to see that you have a volume function and they want to know that they can call that function, but they don't really want to know how you compute your volume. And we can really make things simple for them and hide the implementation details in a separate CPP file. So let's do that. We're going to set up a new CPP file. We're going to call this cylinder.cpp, and we're going to move the implementations of our functions in the CPP file. And I am doing this just to show you that it is possible. In practice, you're going to have to decide for yourself what you want to keep in the header file and what you want to keep in the CPP file. So the cylinder default constructor here is going to stay this way, but we can move the other constructor here in the CPP file. And the way we do that, we're going to just grab this, and I am going to change this line by line so that you can see this. And in the CPP file, the first thing we want to do is to include the cylinder header because the implementations here are going to be using this. And we're going to put in our constructor and modify it to be fit for living in a CPP file. So let's come here and do that. The way we tell this that this is really an implementation of a function we have in our header here is to put the class name in front. We're going to say cylinder and put 2 columns. The moment we do that, the compiler is going to know that this is an implementation of a function we have in our header file. And this is the function here. And now we can take out the body here and leave this as a prototype for the function, which is our constructor here. We can do this. Okay, if we do this and build, the code is going to build, it's going to construct our objects. Let's go back in main CPP and make sure that that's the constructor we are using. It is. We can build and make sure that what we just didn't break anything. We are building, and we can clear things up a little bit and run Rooster. This is going to give us our volume, and we have started to split things up in our class here. Some things are going to live in the header file. Some other things are going to live in the implementation file. So we have moved our constructor here. Let's move the volume function. We can grab it and move things line by line. I think this is the best way to learn. And I think we can move these things a little bit to the left. Let's do that. And we're going to say that this is a function implementation for some function that is declared in the class here. So we're going to say cylinder, and we're going to put 2 colons. This is going to tell the compiler this is an implementation of a function we have in our class, and the return type has to live in front of this scope resolution operator. Okay, what we have here, cylinder colon colon, is called the scope resolution operator, and is basically telling the compiler that our function called volume lives in the scope of the cylinder class. This is what the syntax here is saying, and this little thing here is called a scope resolution operator. Okay, so we have moved our volume function. We can now take the body out from the class and keep the prototype here. We can go down and really practice on the setters and getters. So let's do that. So we're going to grab them all together because now you have the gist about how this works. We can copy them and move them into the CPP file. And we're going to fix the code line by line here. So let's make sure they are aligned properly. We have 2 left to do. Let's do that. And I really have to show you this live because some people are going to have problems regarding how I did this. So I want you to see this live as I do this. I'm not going to edit this out. So we're going to put our scope resolution operator after our return type here. We're going to say cylinder. Cylinder. Can't type, can I? Okay, we have this in. And we can really copy this and paste this in place wherever it is needed. So I'm going to paste that here. I am going to paste that here, and I am going to paste that here. Now we have successfully moved all the functions in the implementation file, cylinder.cpp, and we can go back in our header and remove the bodies because we don't need them here. If we keep them here, we're going to have 2 definitions for these functions, and we're going to have compiler errors. Let's take this out. We're going to take the body out. We're going to take the body out, and we're going to take the body out. Let's do that for a gate base radius here. And now, if we build our program, it should build. We're going to build with GCC. See, the build is good. And if we try to run the program, it should give us what it was given before. This is the volume here. One thing I want you to see is that you don't want to keep 2 definitions for your functions. So, for example, we can grab the body here and bring this back in the header file. I want you to see what's going to happen if you do that. I am going to paste that in here. And I am going to move things a little bit to the right to align things properly here. So if we do this, the compiler is going to see that we are calling that constructor, and the compiler is going to have no problem with this. But once we hit the linker stage, the linker is going to find that we have 2 definitions for the constructor here. We have one in the header, and we have one in the implementation file. And this is going to raise a compiler error saying we have 2 definitions for the constructor here, and the linker wants to know which one to use. So it's going to give you an error. Let's build and really show you this because this can be hard to debug if you don't know what is happening. Okay, you see we have build finished with errors, and the problem is cylinder double is redefined. We don't want to have 2 definitions for the same function. So once you move things from header to implementation file, be sure you don't have any more definitions left in the header, or you're going to have really hard to debug problems. And now I think we have our program organized fairly well for what we know so far about C++. We have our constants living in another header file, and we have learned about include guards, what we can use to guard against our stuff being included more than once by the preprocessor. We have our cylinder class living in its own file, and again we have an include guard here. And you can see that this class now is really easy to look at. We can look at the information about the member functions we have. For example, we have a default constructor, we have a constructor that takes 2 parameters, but we don't see the details about how these things do their jobs. For example, we don't see the details about how the volume is computed. Those details are hidden in the CPP file, and if you want to see them, you need to go to this implementation file here. This is a good design, and I encourage to split your C++ programs in multiple files like this. This is going to make your life easier. We are going to stop here in this lecture. In the next one, we're going to show you that other IDEs provide ways to create classes very easily. It is unfortunate that Visual Studio Code doesn't provide this facility. For now, what we need to do is to create the files like we have done in this lecture, but you have to know that there are better ways to do this, and I am going to show you that starting in the next lecture. Go ahead and finish up here and meet me there.